online, okay? So today we're going to talk about solving multivariable equations. Most of what we've done so far is we've had equations that have just one variable in it, like 2x plus 10 is equal to 25, or 3x minus 7 is equal to 8x plus 2, right? They all have the same variable, x, x, x. Now, when we started graphing on a coordinate plane, remember that? Y equals 2x plus 3, what slope-intercept form? Suddenly, we had multivariable equations. You've been dealing with those while we've been graphing. Y is equal, y, the point-slope form, y plus 2 is equal to 1/2 times x minus 1. That's a multivariable equation, right? Well, sometimes you will be asked to solve for a variable in a multivariable equation. Solve for only one of the variables, and your answer will have the other variable stuff on the other side of the equal sign, because you won't know what those two variables equal. You know what I mean? So, for example, if I had if I had this and it said solve for y, and I had 2x minus 10y equals 46. All right. Is that a multivariable equation? I have an x and I have a y. Anything more than one variable means I have a multivariable equation, right? So, and it's saying solve for y. What does that mean? When it says solve for y, what do I want my final answer to say? Something, something, y. Yes.
Y equals.
Y equals, exactly. So whenever it says solve for y, this is what you're trying to get to. Y equals. That's what you want. And then all the other gobbledygook is going to be on the other side, right? So that's what we got to do. So I want to get everything else over here. I want to get it out of the way. So what would I do first? Gabe, what would I do first? I want the y all by itself. But first, I'm going to keep all the y's together. There are -10 of them. Right? All the negative y's. I mean, whatever. I'm going to keep them all together for now. This is my problem. The 2x is my problem. Anything that's being added or subtracted to 10y. Right? That's my problem. I'm going to get rid of that first. Right? So I'm going to subtract 2x. I'm going to subtract 2x. And then when I do that, I have these cross out, right? So I have -10y is equal to, is that 44x?
No.
Why?
Because there's not an x.
Oh, they're not like terms. Thank you so much. That's what I needed to know. See, those are not like terms, so I've got to keep them separate. I'm going to just say minus 2x plus 46. Right? You see that? Yeah? And then, sorry? What? Well, no, if I did that, look what I did. Then I would be getting more stuff over here. I wouldn't be able to connect it with that, so then I'd have -46 minus 10y is equal to -2x. And then I would have the -46 in my way again. This is my goal. I want it to say y equals. I'm closer to my goal, but it's not there yet. It says -10y equals. So what am I going to do? I'm going to, -10 is doing what to the y?
Multiplying.
It's multiplying. So can I just add 10 to both sides?
No.
Why? Why?
You have to divide.
Right, because I have to do the opposite. It's -10 times y. So I've got to do divide by -10. Now what do I do over here?
Divide both of them by -10.
Yes, exactly. This is the best way to do it. Put a line under the -2x and put -10. Put a line under the 46, put -10. Now I have officially divisioned. I have divided everything on both sides of the equations by -10. So let's see what I get. Negative divided by negative is positive. 10 divided by 10 is 1, so all I have left is y over here. Equals. That's what I was going for. Y equals. That's like so exciting. Y equals. And then, negative divided by negative is positive. And I have 2 goes into 2 once. 2 goes into 10 5 times. So I have 1x over 5. 1x over 5 plus, well actually, let's think about that. Positive divided by negative is negative. So I'm going to put a negative there. And then 46 over 10, well, let's see. 2 goes into both of them, right? 2 goes into 10 5 times, or negative 5 times. And 2 goes into 46 23 times. I think that's what I'll do. I'll just say 23 over 5. Oh, wow, look, we have like terms. I mean, we have common denominators. This is a miracle. What would I do, Kareem?
Oh, I was just going to say you can reduce it to, or the 23 fifths to 4 and 3 fifths.
I can. That would be one way to do it. But another way, I notice since they both have the same denominator, I could do this. I could say y is equal to, I could just do 1x minus 23 all over 5. 1x minus 23 all over 5. I think that's what I would probably be inclined to do. But Kareem's idea is totally fine too. You could do 1x over 5 minus whatever you said, 4 and 3 fifths. Yeah, that would be totally fine. But it just seemed more fun since I noticed that we had the same common denominator. I just put the numerator, I put both of these things in the numerator and just had one denominator. So I have one fraction. Okay, so that is how you solve for y. Now, let's say that your math teacher did this. He said, oops, just kidding.
JK. Oh, that would suck.
Solve for x. That's what he really meant. All right. So what do I have it just have? What's my goal? What's it got to say here?
X equals.
X equals, right? When it says solve for x, that means it's got to be x equals. Oh, bummer. Look at all this mess. We did all this work for nothing.
Thanks, Gary.
Thanks, Carrie.
What are these math teachers thinking about? I mean,
I don't know. Just go to a convention and ask.
Exactly. So suddenly we have 2x minus 10y is equal to 46. What do I do? I'm now supposed to solve for x. So Liam, what would you do first?
Get rid of 10.
I want it to say x equals. What's in the way of it saying x equals? Yes. So what do I do?
Plus 10y.
Plus 10y. Plus 10y. Draw my line. I've got 2x is equal to, these cross out, right? Yes. So now I have 46 plus 10y. What's that, 56y?
No.
It was
It's like 46.
46 plus 10y. 46 plus 10y. Or I could do 10y plus 46, either way. Now what would I do? Liam, what would you do now? You're almost there. It says you want x equals. But it says 2x equals.
Oh. Get rid of. So you divide the 2x.
All right. I put a line under the 2x. I put a 2. I put a line under the 46. I put a 2. Put a line over the 10y under the 10y. I put a 2. So now that crosses out. So I have x equals, what's 46 divided by 2?
I have no idea.
23. Plus, what's 10 divided by 2?
5.
So 2 goes in that once, 2 goes in that 5 times, 5y. Look at that. We just solved for it. Sorry, can you see? Does that make sense?
So you don't have to simplify it?
There's nothing else I can do.
Oh, yeah.
X is equal to 23 plus 5y. There's nothing else I can do,
Graph it.
right? So I could graph it. I could graph it.
Don't graph it.
But I don't really feel like it. But I could. I could. You want me to? If I were going to graph it, I would turn it into y equals. Then I can use my slope intercept form. So let's graph it. Oh no, that means we should solve for y.
Gary.
What was our answer? Does anybody remember?
I do. It's 1x minus 23 over 5.
Okay.
It's 23 over
Y is equal to x. I'm going to put over 5. So really, okay, and it was minus 23 over 5, right?
Yeah.
Okay, now I'm going to go back to, I'm going to correct myself now. Now since I'm going to graph it, I'm going to do a Kareem set, which is I'm going to change this to a number because I want to say y equals mx plus b, right? Right? Well, first of all, what's my m? What's my slope? Indu, what's my slope?
Your slope? The x over 5.
Right, so what's the slope?
Oh. Of x over 5. Something bad. What?
Yeah, but x times what is x over 5? X times what? That's the question.
I don't know.
Yeah, you do. Yeah, you do.
It's like, you know what, you just don't know.
Oh.
X times 1/5. So your slope is 1/5. See what I'm saying? See what I mean? That makes sense? So look. So if I were going to rewrite this in slope-intercept form, I would say 1/5 x minus, and Kareem said 4 3/5, right?
Yeah.
Now, doesn't that look like slope-intercept form? Piece of cake, right? I come over here. I know I go, this is my y-intercept, right? Negative 4 3/5. 1, 2, 3, 4, 5. So it's going to be somewhere around there, right? Yes? You with me? Guys? Negative 4 3/5. And then I'm going to go up 1 over 5. Up 1 over 5. 1, 2, 3, 4, 5. Up 1 over 5. Somewhere in there. Right? And then I draw my line and I'm done. Right?
Yay.
Now, that is actually the practical reason for knowing how to solve for a variable, because then you can, that's one practical reason. Then you can graph it really well. Typically, if you're given a hard problem and I say graph it, simplify it. So for example, let's do one. When does this class end?
Wait, is it
10:03.
Is it 2x plus 10y equals 46? Wouldn't that be standard form?
Yep. Gary, math is over at 10:03.
What? 3 minutes. Go, Gary, go.
Oh yeah, it is in standard form. You're right. You could do that. But so let's.
The schedule's changed, remember?
Oh, yeah. That's why we're here.
Oh yeah, you weren't here yesterday. You don't have a
What time is it?
yet.
Okay. So let's say though I had this and I said graph this. Graph. And I said, 3x minus 4 equals 2y plus 7. Like, ooh. And I've got to graph it. Well, I don't know what to do. Well, wait a minute. Yes, I do. Why not solve for y? Because if I solve for y, it's y equals, right?
Oh yeah.
And what is y equals? What form is that? Slope. Yeah, y equals MSB, called slope-intercept, right?
No.
So we'll do it. We're gonna say, look, I want it to say y equals, or equals y. I'm gonna keep the y over here. Well, actually, it doesn't matter. I could take this, since this equals this, I could flip them, right? I could put this over here and put this here. There's the same thing. So maybe I'll do that because I like my y on the left for graphing. So equals 3x minus 4. I just flipped them, right? See what I did? So that's legal, right? That's legal. They're equal to each other, so I didn't change anything, right? All right. So now look, what's in the way of what's saying y equals? Nathan. That's the stupid 7. The stupid 7. Right. Exactly. That's stupid 7. All right. So 2y is equal to, those cross out, 3x minus 11. Right?
Yeah.
Okay.
Done.
What's in the way of it saying y equals, Sal?
The 2.
The 2. So we're going to divide by 2. We're going to divide by 2. We're going to divide by 2. So in slope-intercept form, we're going to have y equals 3/2 x minus 5.5. So I go over here and I go negative 5.5, right? 1, 2, 3, 4, 5, 6. There's 5.5. And then I go up 3 over 2, up 3, 1, 2, 3 over 2. Put a dot there, and I just graphed it. So I went from this mess to something quite useful and able to graph it quite easily. Does that make sense? So solving multivariable equations just means that you're getting whatever it says to solve for, it's saying that equals something. And that equals, what it equals may have variables in it. That's okay. All right, so that's the lecture.